Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Optimizing WSN Lifespan using Chaotic-YSGA-based CH selection and adaptive Huffman data compression techniques. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research area which is specifically designed for the wireless sensor networks, the IoT and other networks. So here the energy efficient clustering protocol is proposed. So before starting the video, let's talk about what I will cover in this video. In this video, we will initially discuss about the application area where this clustering protocols, whatever we have designed, can be practically implemented. Then we will discuss about what exactly the code is, how to execute it, what are the software requirements for it. Along with that, we will discuss about the current work done in this particular area with the references, and then find the problem in it, and then what exactly we have done in the proposed work, that what is the novelty we have done, and finally we have given the experimental results extracted out after the simulation, and we will give a brief to it. So let's start with the application areas. So wireless sensor network, it is one of the domain which is not recent, but uh, currently it is opted by the IoT and the realistic applications. So this is one of the example. So for the smart agriculture, the wireless sensor network domain is very much useful, which can be combined with the IoT or UAVs, through which at the remote location we can easily do the surveillance or the management of the things. Other application area is for the industrial wireless, in which the machine health, manufacturing, inventory, all that stuff can be monitored even without going to that particular location. Other than that, many other application area where WSN is opted, like in the military application, in the healthcare application, for the security and the surveillance, smart building and cities, for the animals habitat monitoring. So where the human cannot reach directly and sensors can work, there the WSN things can be useful. So the challenge in this WSNs are basically because everything is based on the sensors, and sensors are restricted to the power. So the ultimate goal of the research is to reduce the power consumption and make it stable for the longer period. So frequently batteries are not to be changed. So now let's see that how the code is to be executed, what are the software requirements. So we will give you one of the folder. This is the folder that we are going to give you. It has a folder named code, under which there are a number of files. These are the MATLAB files. So for that you need the MATLAB software with you. So the MATLAB version that you can use is either 2018 or above. Here I am using R 2019A. So let's see how the code is to be executed. You just need to go to the folder, and then path must be copied. Then go to the MATLAB and paste it here. Control V, enter. You can see individual file, whatever was there in the folder, is shown here. Out of it you have to run this main Chaos-YSGA file, and another one is the comp code. So this is the main code file from which we have saved the results and then did the comparison. So in order to run this, you just need to go to the run. Make sure the MATLAB that you are using should be the full version, and you must go to the editor. When you are going to click here, it will go to the editor window, and there is a run section. You just need to click on the run. So whenever you will click on the run, it will start executing the results. As you can see, I'm just going to run it, and it will start processing, and the processing will be shown here. While it is running and is busy, let's talk about that what exactly the application is. So this is the network through which we are processing, and these are the communication rounds those are happening. So the base paper that we have followed for it is energy efficient clustering routing protocol in the WSN, where yellow setup goldfish algorithm is applied. By using the YSGA, what they have done, they have selected the cluster heads, but majorly the parameter that they are considering is the energy. So only energy is not the important factor for selection of the cluster heads, and also the communication must be that effective so that it can easily transmit the data at the lesser energy consumption. So YSDA is one of the algorithm which was successful in many of the application areas, but when we have explored the things, we came to know that YSDA is having few issues, like for the exploration issues and all. It got stuck into the local optima. So you can also read about the YSGA in detail, that what new variants are available for it. So inspired from that, what we have done, we have improved the YSGA process by introducing the chaotic concept. So in this particular model, what we have done, one of the phase what the proposed is like we are reducing the size of the data by applying the lossless compression or encoding technique. So Huffman encoding technique is applied to the system in order to reduce the data. Secondly, for cluster head selection, we are extending the parameter dependency, not only the energy but different parameters like distance to the sink, distance to the node, and the delay. These factors has been introduced along with the energy, so that are given in the cost function that I will show you once it will be run. Then the YSGA is improved by introducing the concept of chaotic maps in the YSGA. So these are the main contribution that we are going to do into it. So you can see initially the configuration is given, which we have taken from the base paper so that we can compare it with that. So all the details you can get from this table. So after the processing, then energy model has been used, which is used in the wireless sensor networks. Then initially the scenario has been generated through which you can see this network has been generated where the nodes are deployed. And then for every round, the tracking of the dead nodes, energy, first node, half node, 50% of node deads, all these stats has been analyzed. Then on the basis of the factors that I was talking about, the YSGA's proposed version has been implemented to guess the best cluster heads. Then the communication among the node and the cluster has been made. So you can, I was talking about that we have extended the parameters. You can see the cost function that we are using here, the energy, average distance, distance to the sink, and the delay. All these factors has been introduced, and on the weight basis, we have calculated the fitness, and the node with the best fit are chosen as the cluster. Then the communication by the energy model has been done, and finally the results has been analyzed in terms of dead node, alive node, energy, throughput, first node dead, half node dead, last node dead. So all these results has been represented. You can see the results. So this was the network. This is the dead node graph with respect to communication rounds. This is for live nodes, this is for residual energy, this is for throughput, and this is finally for the first, half, and last node dead. We also did a comparison. For that, you just need to run this file, which will we have saved the results by using the save command, and those are loaded in this file. When I'm running this, you can see it will do the comparison of different factors with the base paper where DEEC and YSGA system was used. So Chaos and Huffman encoding operated YSGA system is giving better results. So these are the factors where we are doing the comparison. You can see the red curve is of our proposed one. So it is stable for longer period. This is for the live nodes. This is for the residual energy. So the consumption is less. Here the throughput, which is higher in our case. And finally, the scenario where first node 25% of node, 50% of node, or 100% of nodes has been evaluated, that which uh, algorithm is giving how much value. So you can see this mustard is of our proposed technique, which is higher in every of the case, either it is first 25, 50, or 100%. So this is how the proposed technique is proving itself better in terms of multiple factors. Further modifications are still possible, and more complex system can be designed in order to preserve more energy. So either it will be for the doctorate, for the industrial purpose, or real-time applications. The further modifications can be done and can be real-time implementation can be assisted. So for more details, you can contact us directly and get the details. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include Selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.